Okay, so our first task to find dy dt or dx dt is we need to find the derivative of the equation with respects to t. Instead of minus the square root of x, I'm going to think of that as x to the 1/2. So I have dy dt, and then that's dx dt. Now I'm going to clean this up a bit. I want to get rid of this negative exponent. When you have a negative exponent, you can move that to the denominator, make it positive, and I'm going to write it as the square root of x instead of the power of 1/2. So now to find a, I'm going to plug in what I know. So dy dt equals 2 times 4 times 8 minus 1 over 2 root 4 times 8. And when you simplify all that, you get 64 minus 2, so our answer is 62. Now for b, I have dy dt, so 12 equals, and I want to find dx dt. Now on the right side here, it'll be easiest if I factor out the dx dt, and I'm left with 2 times 16 is 32 minus, and this is 1/8. So then if I divide both sides by 32 minus 1/8, I get 32 over 85 is dx over dt. We're going to do the same thing for number 2, except for number 2 we need the product rule. So I'm going to say f is my x and g is my y. So if you remember the product rule, so I'm going to individually find the derivative of each piece. So now to fill in my product rule, I'm going to do x times dy dt plus y times dx dt. That's going to equal 0. So now to answer A, x is 8. I need to find dy dt. Well, I don't know why, but I can find it. If x is 8, we've got 8 times y is 4. So y is 1/2 for part A, times 10. Okay, so let's simplify this. I'm going to subtract the 5 to the other side, and then divide by 8. So it's minus 5, divide by 8. So now doing the same idea for part B. So let's find y for B. X times y is 4. So in this case, y is 4. So now we've got negative 6 plus 4 dx dt equals 0. I'm going to add 6. And then divide by 4. So dx dt, well, this can reduce to 3/2. So now looking at number 3 as a word problem. If the radius is increasing at a rate of 2 inches per minute, that means dr dt is our 2. And I want to find the rate of change of area, which is dA dt. So first I need to know what is the area of a circle, which is pi r squared. So then the derivative of that with respect to time so for part A, I'm going to plug in what we know. Now for A, the radius is 6, changing at a rate of 2 inches per minute. So when I multiply those, I get 24 pi inches squared per minute. In part B, I'm going to fill in. In this case, the radius is 24. The rate of change of the radius is still 2. So that equals 96 pi inches squared per minute. Okay, so for number 4, the balloon is inflating at a rate of 20 cubic feet per minute, so that means dV dt is 20. How fast is the radius changing? We need to find dr dt. So first we need the volume formula of a sphere. And then we have to take its derivative with respect to time. When I multiply this 3 down, it becomes 4. So now for part A, 20 equals, the radius is 1. So we have 20 equals 4 pi dr dt. So we need to divide both sides by 4 pi. So reducing this by 4, I get 5 over pi, and it is feet per minute for dr dt. I'm going to do the same thing for part B. 20. But in this case, the radius is 2 feet. So 4 times 4 gives us 16 pi. We divide both sides by 16 pi. And again, we can reduce this by 4. So I get 5 over 4 pi feet per minute as our rate of change over time for the radius. Okay, so for number 5, the weekly advertising costs are $1,500. Well, okay. Well, and if it's increasing at a rate of 125 per week, that is dx dt. And the costs, it says the advertising costs are X and the sales are S. So if we find our derivative of our equation here of the sales with respect to time, the derivative of a constant is 0. Now for the next piece, we get 50 dx dt plus 0.7x dx dt. And we want the rate of change of the sales. So I'm going to plug in everything I know. I need to find ds dt. Our x is, our dx dt, the rate of change is 125. The 1500 is x. So simplifying all that, we get $137,500 per week. Okay, for number 6, it's a cube. So thinking of the volume of a cube, that's x times x times x, so that's x to the third. So dv dt, the change of the volume over time, is 3x squared dx dt. Well, they give us that the edge is expanding at 3 centimeters per second, so that's dx dt. So part A, the change in volume over time is 3 times the edge is 1 times 3, so we get 9 centimeters cubed per second. And for part B, now the edge is 10, so that equals 900 centimeters cubed per second as the rate of change of the volume. Now for number 7, finding the dy dt, do that over here, dy dt is 2x dx dt. And so to answer parts A, B, C, and D, we would plug in all of the x's to our formula. So I'll do A, find dy dt. So 2 times negative 3, and dx is 2, so that is negative 12 centimeters per second. For B, plug in 0, that is 0 centimeters per, oops, I'm sorry, it's not seconds, it's minutes. Fix my units here. Centimeters per minute. And you would do the same thing for C and D. Now for number 8, here's our house, the ladder. The ladder's 25 feet. Now the horizontal x and the vertical y. Well, my formula to start, I'm going to use the Pythagorean theorem. X squared plus y squared is 25 squared. So finding the derivative of each piece, it's going to be 2x times dx dt, and then the derivative of y, 2y dy dt, and it's going to equal 0. So this is the formula we're going to use for all 3 pieces. So now for part A, we want to find how fast the ladder is moving down the wall. So that's dy dt, that's the vertical distance. And because it's going down, my answer should be negative. So in part A, if x is 7 squared plus y squared is 25 squared, I need to find what y is for every single piece of this problem. So for part A, y is 24. And we had x is 7. And I can find, oh, nope, they give us dx dt right here, 2 feet per second moving away. So for every problem, dx dt is 2. So plugging in to my derivative, 2 times 2 times x plus 2 times y dy dt. And now I have to simplify that. And 2 times 2 times 7. Okay, so there's my calculations. I'm going to subtract the 28 over, divide by 48. So dy dt is going to simplify to negative 7/12, and that is feet per second. That is moving down the house. Now you're going to repeat that for parts B and C with different x values.